Hello, my name is Adarsh. I'm a tutor and I help prepare students for the SAT and the ACT exams. Today we're going to be doing a couple ACT problems to give you a glimpse of what my tutoring looks like and hopefully to get you excited for that. So let's get started. The first problem we have here says, at the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of the coins. What is the expected value of x? In this problem, the expected value refers to the average number of points that we can get by adding up all the possible scenarios. So if we have a coin will give us 2 possible outcomes, which will be heads or tails. And since we have 3 coins, the number of possible scenarios that we can have is 8. So for each scenario, we're going to calculate the number of points that we can get. Remember, for each coin that lands heads up, we're going to get 3 points. So the first scenario could be heads, heads, and heads, which will give us 9 points. The next scenario could be heads, heads, and tails, which would give us 6 points. The next scenario could be heads, tails, and heads, which would give us 6 points. The next could be heads, tails, and tails, which would give us 3 points. The next could be tails, heads, heads, which would be 6 points. The next would be tails, heads, and tails, which would give us 3 points. The next would be tails, tails, and heads, which would also give us 3 points. And finally, tails, tails, and tails, which would give us 0 points. So I'm just going to fix that right there. So when we add all these up, we're going to get 9 plus 6 is 15, plus 6 is 21, plus 3 is 24, plus 6 is 30, plus 3 is 33, plus 3 is 36 total points. And so we have 36 total points from all these 8 scenarios. We're going to take those points. We're going to divide by the number of scenarios we have, which is 8. And we're going to simplify this fraction. This is going to simplify to 9 over 2. And if we look over right here, we have that right here. So the answer is going to be 9 over 2. Moving on. Our next problem says, for what positive real value of k, if any, is the determinant of the matrix k for 3k equal to k? Note, the determinant of matrix ABCD equals AD minus BC. And so the way to approach this problem is to first figure out the determinant for this particular matrix here. So that's going to be k squared minus 4 times 3. And if you don't know what I'm talking about here, it's what they show you right here, AD minus BC, which is k squared minus 4 times 3, which is just k squared minus 12. So that's the determinant. And they're asking for when the determinant is equal to k. So we're going to set up an equation, k squared minus 12 equals k. We're going to move the k over to the left side to give us the equation k squared minus k minus 12 equals 0. And now we can factor this into k minus 4 and k plus 3 equals 0. And so our 2 possible scenarios are when k equals 4 and when k equals negative 3. So we have 2 possible answers here. But note, the problem says positive real value of k. Positive. And so the answer must be k equals 4. So just to make sure we have an answer like that, we're going to move over. And yes, indeed, we have k equals 4 right here, which is B. And so our answer to this problem is going to be B. Moving on. Our next problem says, given a positive integer n, such that I to the n equals 1, which of the following statements about n must be true? And so we have to remember what I is, and they kind of give us a hint here in the problem. I squared equals -1. So basically I to the first power is going to be I to the second power is going to be -1, as they show us in the note here. I cubed is going to be I times I, which is -I. I4 is going to be I times I, which is just 1. I5, I to the 5, is going to be I. And you're going to see that this just repeats itself. So it's just a repeating series here. So now we have to figure out for what values of n, I to the n, does I to the n equal 1? So from our little chart right here, we see that I to the 4 equals 1. And if we were to keep on going, some other values for which I to the n equals 1 is I to the 4, I to the 8, and basically any value of n which is a multiple of 4. And so for I to the n to equal 1, n has to be a multiple of 4. So that means when n is divided by 4, the remainder has to be 0, which means our answer is going to be F. Moving on, the next one is about trig here. And it says, for what for negative pi over 2 to pi over 2, the absolute value of sine theta is greater than 1 is true for all and only the values of theta in which of the following sets? So they give us sine theta is greater than or equal to 1, which is the same thing as saying sine theta is greater than 1, or sine theta is less than -1. So if you remember the sine function, all values of sine theta are going to fall in the range from -1 to 1. So all the values in between -1 and 1 don't matter in this case because they have to be greater than 1 or -1. So the only values that will work here are the values for which sine theta equals -1 or 1. And if we remember our unit circle, the only values for theta for which sine theta equals -1 or 1 are pi over 2 and 3 pi over 2, which is the same thing as negative pi over 2. And so that should be our answer. And just to see here, the two problems the two answer choices which look pretty enticing here are this choice right here and this choice right here. What's the difference? Well, this choice includes all the values from negative pi over 2 to pi over 2. We don't want that. We want just the values negative pi over 2 and pi over 2. So A is going to be our answer. Moving on to our last problem for today. This is some geometry right here. It says ray PK bisects LPM. I'm just going to draw that real quick. We're going to have angle L right here. Start to draw dots here. P and M. And we're saying PK bisects that. Okay. Cool. So rate PK bisects LPM. The measure of LPM is 11x, and the measure of LPK is 4x plus 18. What is the measure of KPM? So based on the problem, we know that this angle right here is 4x plus 18. And we also know that PK, this ray, bisects the angle LPM, which means that this angle and this angle are the same thing. So we can write 4x plus 18 right here. So these two angles are the same thing, and they both equal 4x plus 18. The problem also tells us that the angle LPM is 11x. And we know that LPM is the two little angles combined together. So based on that information, we can write an equation where we say 4x plus 18 plus 4x plus 18 equals 11x. And to simplify that a bit more, we're going to add some terms here, and we're going to get 8x plus 36 equals 11x. We're going to subtract 8x from both sides. You know, this is basic algebra, so we're going to say 36 equals 3x. Divide by 3, and you're going to get x equals 12. Cool. So we got x equals 12 as our answer, but the problem is not asking for the value of x. And if we were to make that mistake, we would choose the wrong answer, 12, as our answer. But the problem is asking for the value of angle KPM. Angle KPM, not x. So to find the value of angle KPM, we know that angle KPM right here, this angle, is going to be equal to 4x plus 18. And so to figure that out, what that angle actually is, to get a value for that, we're going to take our x value that we got right here, and we're going to plug it in to this equation, this expression. So we're going to have 4x plus 18, which is 4 times 12 plus 18. That's going to equal 48 plus 18. And if we add that up, 48 plus 18 is going to give us 66 degrees. And if we look over in the answer choices right here, 66 degrees is going to be one of our answers. So that about wraps up the ACT problems for today. These are part of a previously released ACT exam, so if you want to go check that out, you're going to find that these answers are indeed correct. If you want more content, please feel sure to reach out to me, to subscribe, to like this video, or anything in the comment section. I will be releasing more videos like this with practice ACT, practice SAT math problems, and also practice ACT science problems. So be on the lookout for that. Thank you.